Okay, let's just look at the last two units of the integral of chapter 17. So what we want to look at is this idea of the area between two curves, because that's going to make our life much easier. So before we do that, I just want to look at like an exercise from the book. They ask you to find the integral from -2 to -1 of 1 over x dx. And looking at 1 over x dx, we know that here's the right branch and here's the left branch, and we know that here's -2, here's -1. We know we can find the area of this. We know it exists. We know it's going to be negative. We know it's going to be a negative number, but it's still a number that we can find. So when we take the integral, we know it's ln of x from -2 to -1, but we notice that ln cannot take values less than 1, less than 0. That's why the integral of 1 of the x, remember, it's the absolute value of x. And so you have the ln of the absolute value of 1 minus the ln of the absolute value of -2. It's the ln of 1 minus ln of 2. We get negative ln of 2, but it's underneath the x-axis. We're fine with that. So that was just a side thing. So let's continue on. So a question they might ask you is, find the area of the region bounded by the curves y equals x squared and y equals radical x. And at this point, you're pretty good. You know how to make a sketch, or you can use your GEC, but you know what, we're going to make a sketch. And we know radical x is greater than, because we're back to the real numbers, we know radical x is greater than 0. So we know the curve looks something like this. And x squared is a parabola, so, it looks like this. And what we're interested in finding this region, let's call it A. Right? And so if you think about it, so once again, how do we find the area? Well, we know we use the integral, right? And the integral is all about the rectangles. It's all about the rectangles. So where are the rectangles going in here? Here's my rectangle. Here's my rectangle. Here's my rectangle. So we know it's the integral. So it's about the rectangle. Okay. First thing you're going to do is find these intersection points. Well, by inspection, I know that this is 0, 0, and I know that this is 1, 1. If it gets more difficult, you can use your graphing calculator. So I know it's the integral from 0 to 1, and I know that my dx, the question is, what is the height of my rectangles? Well, this is just distance. And so it's going to be upper curve minus lower curve. So this is my upper curve, and this is my lower curve. Right? And so it's radical x minus x squared. Every single place here in the region, upper minus lower, will give me my rectangles. Once again, I want to find the sum of the infinity of these rectangles. That's the idea. Always think about the rectangles. So the area between two curves, in general, is the integral from the lower limit to the upper limit from the upper curve minus the lower curve, dx. Once again, it's all about what is the height of these rectangles? Well, let's just do the math. So it's radical x is x to the 1/2, so it's x to the 3/2 divided by 3/2, so it's 2/3 x to the 3/2 minus x cubed over 3. From 0 to 1, we have 2/3 minus 1/3. I don't have to do the 0 because it cancels out, and the area is 1/3. Let's try another one. Find the... Oh, so let's think about this though. So before, we were finding the area between the curve and the x-axis. But you know what? If we think about the x-axis as a curve itself, y = 0, then we can apply this formula. So let's erase this. So, for example, where's my notebook? Here it is. So once again, technically, the integral from a to b of f of x dx is the integral from a to b of f of x minus 0 dx, and this is the x-axis. Right? And that can be very helpful. That helps us bring our formula together. So, for example, going back to the first problem, if I solve this graph, I knew it was a sine wave, and I was asked to find the area here, area 1 and area 2, I can now take a different approach. I can say, you know what? Once again, it's all about the rectangles. So I look at the rectangles here, rectangle, rectangle. I'm going to use a different color. Now I'm going to look at these rectangles in green. Right? So it makes a little difference now. Once again, it's all about the rectangle. It's all about the rectangles. So let's take this first part. We know it's the integral from 0 to pi. What is the upper curve? The upper curve is sine. The lower curve is 0. You know what? Let me use, I'm sorry. Oh, that's good. That's for here. Now, sorry, you know what? I want to erase, I'm going to use the colors that I used. So, let's start with blue. Once again, this is from 0 to pi, and the upper curve was sine, and the lower curve was 0. I'm going to add that to my green region. Now it's changed. My upper curve is the x-axis, and my lower curve is sine. So in this case, it's going to be from pi to 2 pi of 0 minus sine of x. This will help me get a positive area. Once again, upper minus lower. It always gives you a distance between, it always gives you a positive distance. Now we can work it out, and we get a better answer. What is the integral of sine of x? Negative cosine of x. This is from 0 to pi, plus, what's the integral of negative sine x? That's cosine of x. From pi to 2 pi. And you can work that out on your own. Or let's do it together. The cosine of pi is negative 1, so this is 1. And the cosine of 0 is 1. The cosine of pi is negative 1. So we're subtracting negative 1. This gives us 2. Yes. Yep. Now, you can work on it on your own. What is the, no, I'll cut that out of the video. So let's start over again. The integral of sine of x is negative cosine of x. We're looking from 0 to pi. The cosine of pi is negative 1, so we have positive 1 cosine of pi minus negative cosine of 0. So the cosine of pi is negative 1. We have 1 minus the cosine of 0 is 1, negative 1. This part is 2. Good. And we don't need to do this because we know that's 2 also, but let's just go through it because this might be a part 1 question. The cosine of 2x, so the cosine of 2x is 1 minus the cosine of pi is negative 1. That's also 2. 2 plus 2 is 4. Good. Okay, let's move on. Now, sometimes you have to try this one on your own. Find the area of the region bounded by the graphs y equals x and y equals 2 minus x squared. I'm going to give you a sec. Why don't you pause the video? I want you to sketch these graphs and see if they have intersection points. Okay, so I'm going to make a sketch on the side. I know my first graph is a line, y equals x, that I'm not going to do quickly. The question is, what is this next graph? Oh, you know what? That's a parabola, it's a smile, it's x squared, it's a frown, and it's moved up 2. So we know it looks something like this. Okay. First, find the intersection points. Now, you can try this. If it's part 1, you have to do it by hand. So we have x equals 2 minus x squared plus x minus 2 equals 0, x plus 2, x minus 1 equals 0, x equals negative 2, and x equals 1. Okay, so we're interested in finding this region. Once again, it's all about the rectangles. It's all about the rectangles. Put your rectangles in. Rectangle, 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 rectangle. Okay, so we're in luck because there's clearly an upper curve and there's clearly a lower curve. So, let's start the integral. The integral from negative 2 to 1. What's the upper curve? Oh, the upper curve is my parabola. 2 minus x squared. What's my lower curve? My lower curve is the line y equals x. And the whole thing, dx. You must show this to get the method point. Or you might even get more for the lower and the upper limits. If you can't figure it out, make up numbers. If you know that you have an integral and you can't figure that out, just make up stuff. You'll get points for the method. Let's just do the math. We have 2x minus x cubed over 3 minus x squared over 2 from negative 2 to 1. So we have 2 minus 1/3 minus 1/2 minus negative 4. So we're subtracting that, so we're going to get a positive number. What's going on over here? That's negative 8. So that's positive 8 over 3. And what's going on over here? That's minus 2, because negative 2 squared is 4, minus 2. Hopefully the math works out. It does, because we have the 9/3. So 2 minus 1/2 That's 1.5, 5.5, 7.5, and this is 1/3 minus, so it's minus 9/3 or minus 3. Final answer, 4.5. Check that for me, see if I got that right. Let's look at another example in which the curves might not intersect, but that's okay. So, let's see. Find the region bounded by y equals x squared plus 3 and y equals negative x between 1 and 1. Between negative 1 and 1. Now, I'm using really basic polynomials. Obviously, you can see that, like, we can do trig or e to the x, but I'm keeping it simple. Once again, it's all about the rectangles, the upper curve, the lower curve, and where the intersection points are, or where the rectangles start and end. Let's take a look at this graph. Pause the video, sketch that. Okay, we're back. So let's get a graph. X squared plus 3, I know it's a parabola, it's a smile, it moved up. Y equals negative x. It turns out that it doesn't intersect. And the question is between 1 and 1. So we have the region here and a region here. And so what we're interested in is finding this region here. We're interested in finding the region bounded by the two curves and these lines right here. And so this is how we can, find the area of these weird shapes. The question is, how do we find the area? Once again, it's all about the rectangles. Put in your rectangles, rectangle, 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 rectangle. You go, okay, I have an upper curve and a lower curve. That doesn't change. Pay attention to the sine curve. You have to say to yourself, wait a minute. Is it like, is what's upper, what's lower, and is that changing? Okay, so they may not intersect, but we're told to start the rectangles at -1 and stop the rectangles at 1. So let's just put it together, all right? I'm not even going to solve it. We have -1 to 1. The parabola is the upper. The line is the lower. So we have x squared plus 3 minus negative x dx. So we have the integral from -1 to 1, x squared plus 3 plus x dx. And you would just, you figure this out on your own or put it into the graphing calculator. Did I figure this out? No, I did not. Let's do one with the graphing calculator. Let's do a problem with the graphing calculator. I want you to find, the area of the region bounded by the graphs y equals 1/2 x plus 1, y equals 1/2 x plus 1, and y equals e to the x. First of all, I can make my graph, but you clearly, you know that I'm going to be asking you to find the solution. You know that somewhere along the line, the intersection points are going to be by the equation e to the x equals 1/2 x plus 1. Immediately, without even thinking, you need to say to yourself, without even thinking, whoops. Are you still going? Yeah. Without even thinking, you need to be like GDC calculator. Maybe you figure out the first point. You know it's 0. Maybe by looking at the graphs. But you know what? GDC. Get the sketch down. Get the sketch down. Now, I had trouble sketching this. I needed to look at my graphing calculator because I wasn't getting this right. It turns out that it's like this is e to the x, and this is so it turns out this is the line y equals 1/2 x plus 1, and this is the line y equals e to the x. And so we're looking for this region here. First things first, use your graphing calculator. And at this point, we're back on the graphing calculator. You could use Desmos, but I want you to practice on your graphing calculator. You have to find these intersection points. It turns out that this is x equals 0. Can you find out? Pause the video. The answer is negative 1.6. So, once again, it's all about the rectangles. It's all about the rectangles. Rectangle, 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 rectangle. You're good to go. Put an integral together. The integral from negative 1.6 to 0. What's the upper? What's the lower? Well, it turns out the line, this is the upper. And e to the x in this region is the lower. We know that an exponential function will grow faster than the line. But right here in this region, no. The linear is above the exponential. So it's 1 over x plus 1 minus e to the x. dx. Use your GDC. Math, calculus, integral. Put all the numbers in. The final answer? 0.162. Anything else you want to talk about today? No, I'll make another video. Thank you.